All right. Let me find my window with perf stuff. There we go. All right. So, pull requests this week. Let's see. I didn't see anything that was explicitly new, but with Thanksgiving, that's not super surprising, I guess. A lot of stuff closed though. So let's see. Patrick had a PR to release free heap pages after trim in the MDS, similar to what we do in both the OSD and in the Mons now. This isn't using the priority cache manager or any of that stuff, but just was kind of a quick fix to resolve issues that came up in testing with containers where the MDS was being killed because it was using more memory than it was expected to be using. So hopefully that will help there. Let's see. There's this PR from David, balancer fixes. I don't remember exactly what the status of that was. I think it actually got merged before he intended it to, but I think there may be a couple of additional fixes coming with that. There's this MDS CPU affinity PR that merged. This is simple PR, but increasing the autoscaler's default PG num count to 16 from, I think it was 8 before possibly. That just makes it a little bit nicer when you don't have much data yet in a pool. It gives you a couple more PGs to work with and more parallelism. I think long term, I'm hoping that we will still modify the autoscaler's behavior to not have low PG counts unless there's pressure to, rather than just kind of defaulting to a low count. Instead, maybe default to say 100 or 50 or something per OSD rather. Sorry, not overall, but per OSD, and then when there's pressure from other pools, then start shrinking them rather than just kind of like slowly growing them from a very small count. But we'll see. This is a good step in the right direction. This replicated write log core codes part 1 that merged. Oh, and actually there is a part 2 that probably should be under new. I happened to see that but didn't list it here. So that was the one that we talked about previously, where it was a part of a much bigger PR. So next, enhance OSD NUMA affinity compatibility that merged. I don't remember everything that did, but I think part of it was like looking at bonding setups and properly like recognizing if a bond was on the same NUMA node as the rest of the OSD, then actually set the affinities right and everything. Previously, it didn't do that. So it was that, amongst other things, I think, that just made the NUMA processing code a little bit smarter. Let's see. Oh, the delete range stuff merged, so that's really good. That was a PR I submitted, but was really actually based on another PR that had previously been merged, but then sort of got overwritten later by some other code. So that's good. We need to be very, very careful about delete range. It turns out it's still quite impactful when it's not used very carefully. Let's see. Oh, the onode cache pinning code that I wrote merged with a fix from Josh, and it looked like it was working fine. It's been working in master for like a week or a week and a half, and then Sage hit a seg fault in that code, but unfortunately didn't have a core dump. So I think the plan right now is to just wait and see if we hit another one and hopefully get a core dump. If not, I guess we'll just keep this in mind. If it is core dumping, or if it is seg faulting, and it is where I think it might be happening, it may be possible to avoid it by wrapping the O node in another container that then we move between the internal lists and the cache, so that we don't kind of keep moving the reference count in the O node back and forth by moving it around inside the internal cache list. But I'm not in love with that idea, but it might be a way to avoid it if it is what I think it might be. So anyway, that's going to be observed for a while. Next one, the rest of these all just got closed by the stale bot. They're all super old and no one was looking at them. So yeah, if one of those is yours, I guess, go back and reopen if you care about it. Couple that were updated, the IOU ring IO engine, I think Kifu ran that through testing and it hit some failures. So that has not gotten merged. Sage updated this collections list plus PR of his. That was kind of old before that, but he did something. I didn't look closely at what it was. My refactor of DuoSD ops, there's been no new work on that. Only I'm trying to keep it in the back of my mind here. I think the way I want to approach that is break it up into smaller PRs. It was really big and it was failing in kind of unexpected ways in just a couple of areas, I think. So probably most of it could still go in and then get in and not become outdated so quickly every time that giant switch statement gets tweaked. And then the specific areas where it was not working right, I could focus on as a separate thing. Let's see, this PR from Majian Peng needs a rebase now. I think it was buggy, it wasn't passing testing, so it needs more work. Or maybe it got updated, but it hasn't been retested, I think, and now it needs another rebase. That's it. And then Igor's BlueStore version 2 framework for intelligent DB space usage that got updated, but then was failing testing, so it needs looked at again as well. That was it for stuff that was updated. There's other stuff in here from Adam that looks really good. It just hasn't had any work done recently. This refactor in some of the RGW code that, Matt, I think you especially were expressing your joy about. What was that?
What's changed?
Oh, the Adams refactor that cleans up a bunch of.
Yes. The string stuff, yeah. Plus extra magic. That's very good change.
Yep. And then there's Eric's filtering stuff. I don't think I've seen anything new on that recently.
I've been doing other things to return to that. Yeah.
Oh, okay. Yep. Sorry, Eric, I didn't see you there. So, but yeah, that looks good. The distributed data cache piece, Mark, I think you're working on that, right?
Sorry. Yes, it's still going on slowly as there are other issues fighting for attention.
Sure. Very cool. No new work very recently on the VLA stuff. Hoping that gets in, but understand it's probably not super high priority.
We just covered that in the RGW PR scrub, and we looked at it's a lot of commits, but they appear to be against single files, so we're hoping that a rebase would be pretty trivial. I don't know if Jesse can do that, but if somebody else is interested in trying, then sounds like we could get at least some of it in.
Sure. And as individual files, I imagine you could probably break it up if you needed to.
Yeah.
Let's see. Otherwise, we've got auto tuning of the MDS cache memory limit. That's gotten more updates. Well, no, it hasn't. I guess at one point it did. No movement in the last 2 weeks, though. And then there's just other various things here that are still on the list but haven't been updated recently. So, all right. That's it for PRs. Anything I missed from anybody?
Hey, Mark, can you hear me?
Hey, Philip.
Yay.
Yes.
I was wondering what the status was of the documentation memory change.
It's my fault and I haven't done it.
Okay.
I did put some text in the Etherpad though for what I was thinking of changing it to. So if you want to take a look,
where is that? Where would I find that?
I just linked it in the chat window.
Okay. And is there any type of PR that I can track and not bother you about it?
Not yet, but I will submit one with this change if folks think it looks reasonable. So
Okay.
it's yeah, if you don't mind, just take a look in the Etherpad here. It's just scroll down a little bit. It's under the discussion topics for 11. Oh, whoops, not 1114 for 1205.
Okay.
Now it's for 1205.
Okay.
What do you think of that? Basically, setting the OSD memory target below 2 gigabytes is typically not recommended. 4 gigabytes is the current default to kind of balance memory requirements and OSD performance. And then setting it higher than 4 gigabytes may improve performance when there are many small objects or many objects or very large data sets being processed. Does that seem like a reasonable statement?
From my perspective, yeah.
All right. Well, I think we'll go with something like that then, unless anyone has any objections. All right, Philip, I will submit a PR for that today, and then I'll send you an email and let you know.
I appreciate that.
Where it is. Yep, no problem. All right. I don't have anything else for today, guys. Anything anyone would like to bring up or talk about?
Yeah, man. How come you don't have persistent memory DIMMs in the lab?
Intel might give us some Optane DIMMs, but they didn't have them ready when they shipped out the.
They've been saying that for a while.
Yeah, that's true.
At least that's what Reddy and Tushar said. Springtime. So,
sure.
No, I mean, have you heard any status on them? Anybody here? I think I've seen somebody even publish the numbers from them.
Yeah, I don't know.
Are we just being shorted, or are they just not there?
I have not seen those numbers, but that doesn't mean they don't exist. Orlando, do you guys have any in your lab that you've been testing?
Sorry, can you guys hear me now? I think I was muted.
Yes.
Yeah, we're actually still trying to scrounge up some more samples in our lab as well.
Actual
but
Optanes,
I have heard, the Optane persistent DIMMs or whatever. I have heard that others out there, like other customers that we've been talking to, that they have tried using the DIMMs for RocksDB, Wall, and DB, but their initial test results showed that basically didn't have any performance benefits. But they didn't have much time to do some testing. Yeah,
that's not surprising based on Mark running it on pure memory.
Yeah,
right.
Yeah, it's like
there are other
CPU.
bottlenecks right now. Yeah,
correct. Yeah,
but however, I have hope for the future.
Yes, I think
Sorry,
if we,
I
agree, Brett. I think we're gonna have to break up the transaction model in BlueStore, or just switch over to CStore or whatever, right? Because with the way that we shove everything into one transaction in RocksDB and go through that whole long write path for everything basically. With like small I/O, it's just the model kind of whether or not you're on an Optane DIMM or Optane or even NVMe, you're not seeing much different performance.
Well, it'd be great. I mean, it'd be nice to be able to find some benefit with it for BlueStore. Looking at production clusters, that might take years to get to 4.0 because of their size and things of that nature. It'd be nice to not, like, every time we roll
4.0 doesn't even help them doesn't even get them there if we're waiting for C-Star. That's getting right.
No,
we're talking about.
I'm saying something different. It's like we keep inventing new stores. Actual production customers it kind of inhibits them from upgrading sometimes.
Well, yeah.
Although it's fun to invent new stores, so we have to balance that somehow.
We haven't been inventing new stores actually very aggressive. Okay, forgive me. We used to be able to invent new key value stores. Now we're inventing. We really do need a new store.
We do. We absolutely do.
I personally think that what's going on in C-Star is the right approach. It's the first thing I do, and so I'm very pleased with it. But
good.
This conversation is kind of, I don't know, it could be a rat hole. There's a lot of, it's no longer trivial due to this. The same thing that Marcus mentioned, that you just mentioned, is also why we can't really move laterally in the right path at all in BlueStore. If BlueStore is, I would love to propose someone or people work on making that possible, but I don't hesitate to admit that it's a big lift. I mean, being able to try out other right, not just have a simpler right path for RocksDB, but ways to try other things. These would be effectively new stores, but compatible with the traditional OSD code base.
No,
this leads to. Pardon?
So what I'm just talking about the difference between production versus development. That's all.
Yeah.
But the
current entanglement of RocksDB is very deep.
Yeah. So
it's usually super trivial to try different things. No, it's not.
A completely different topic we could talk about is flow control.
Oh. No, before we move on, I wanted to.
We absolutely need to talk about that topic. I'd love to talk about that topic.
Yeah. So Josh
let's improve performance by not having OSDs blow up.
Sure. There are details, however. But anyway, go ahead.
Yes, Josh and Neha, how bad would it be to treat the in-memory log representations as persistent without even touching the key value side of it? Like, just get the key value side of it out of it and just use the in-memory representations directly.
Great idea, I think.
You mean for persistent memory?
Yeah.
Yeah.
Yeah, I think that would be fantastic.
Could we do it easily if we just wrote into the
persistent memory? Yeah.
Yeah.
See why not?
And you would make Yaniv so happy because he keeps saying that the significant difference with persistent memory is that it's persistent. It's memory that's persistent. In other words, you can load store, and it doesn't go away.
So the one.
You sure about that? That sounds kind of.
The thing right?
I'd be worried about would be you still have a limited number of write cycles, right? You can't treat it exactly like persistent memory.
Yeah.
I think we should, and then we keep throwing the failures at Intel and say fix it.
Yeah. Well, the thing you want to be careful about is it's not transactional, so you have to.
Right.
If you want to keep it transactional, you have to make a slightly more complex structure than exactly what we're doing in memory today.
That's true. Yeah.
Excuse me. There's two kinds of NVDIMMs. One is like the flash-based, which is where your write cycles would come into play, and then the other one is what's called NVDIMM-N, where it's basically just like a regular memory module, but it's basically it backs up to flash if there's a power failure, and that kind you don't have
a self-contained battery.
What?
Does it have a self-contained battery?
I'm trying to remember how it works.
I think I can demonstrate prior art.
Yeah, some do.
Capacitors usually.
Yeah, some DIMMs
Super
have them
caps.
on board,
Super
some of them
caps.
have off.
Oh, okay, there you go. That's how they
Super
got around
caps.
it.
Yep.
Okay. In that case, we
You
don't
have to
need to worry
wear
about
It's widely
transaction.
deployed.
We have the super caps.
Yeah.
So, I mean, but the point is, it's basically just like RAM, except it doesn't go away. So, I don't see
You're
that
right.
you have to worry about write cycles there.
That's a different model. Well, and it's faster.
Well, it's faster, and I think those are widely available parts.
Yes.
I mean,
Yes,
we have them in
right.
our lab.
Violin was making something like that years ago, I thought.
Yeah, but like Dell, you can buy Dell servers with NVDIMMs.
Yeah.
So
Awesome.
the point is,
And NASA's had motorcycle batteries, but in any case,
you
No,
don't
not
actually.
really,
I did the math. You don't need that much. I mean, this was years ago, but you know.
well, for certain things, you need very high, low latency, but you don't need a lot of memory. And
okay, so it's time. So the time of this is long. Time for the time has come. We've been talking about this for a long time. Is it now tractable to do this? Just
Yeah, let's. I'm putting together a document. Literally started 5 minutes ago and realized I was late for this meeting. Where, as we talked a couple of weeks ago, Matt, putting together sort of a working group to figure out how to take advantage of storage at Red Hat. I've had side conversations with Tom Coughlin, with Sagi from Brett Compton's team. I'm just going to share it out as widely as possible, and let's start throwing stuff at it and figure out what we can do.
So Brett, can we get a couple of like development machines that we have these things in them, so that we're not like trying to timeshare?
I will say yes, and I'll try to make that true.
Okay, they're not that expensive.
Yeah, I mean, buy a freaking server and buy some DIMMs and expense it.
Okay.
I mean, low end server.
For the PG one, wouldn't that be the perfect thing?
Yeah,
absolutely. But I mean other things too. That's absolutely the critical path for it.
Yeah, and if you need yells, I'll say, hey, this was for that project.
So Josh and Neha, back to you guys. What are the things that we need to do or worry about if we were using not the Intel ones necessarily, where we have some other constraints that we need to think about, but on the NVDIMM side, where it's looking like traditional memory with battery back to flash, is there anything there that we need to think critically about compared to how we do it now?
So if we got the battery back to flash, the supercapacitor to flush things out, so we don't have to worry about transactions, that's very simple. I don't think that. I guess we want to be.
How do you allocate memory for that thing?
What does the interface look like?
Right now, we do it out of the memory pools, right? So we would change it there, presumably.
Okay, so would you be using some mutated TC malloc, or would you have a separate memory allocator for that kind of memory, or what would you do?
Yeah, it seems like we want to be able to specify exactly where we're using this. So
yeah, I think TC malloc would be hard to.
Yeah.
So.
Can we use placement new in that situation? Just basically do grab the entire memory range up front and then just grab stuff out of it? Would that be a reasonable approach here?
Yeah, that might work.
Yeah, I mean, the PG log sizes are pretty much bound, so I mean, we could technically do that.
It's not a strict bound right now, but it's with the sizes of NVDIMMs, I think it's not going to be a problem. It's on the order of hundreds of megabytes.
We always allocate new. We don't just have slots that we put in, do we? Allocate.
No, it's not fixed size. It's not fixed size.
Yeah.
I would I would encourage you guys to go look at the persistent memory APIs that have come out of SNIA. They basically address how things are allocated. There is still transactional issues because updates can still be stuck in the cache at a time of a power failure, and you can have inconsistent structure updates and things of that nature. And the persistent memory APIs that are coming out of SNIA address all of that, right? So you might want to take a look at that stuff.
Yeah, exactly. There's libraries, aren't there? That
yes, there are, and they're available in Windows and Linux. They're widely available because they had to do that to get adoption started. And regardless if it's an NVRAM type of thing with DDR backed with supercapacitors, or even the more solid state stuff from Intel, if they're in the DDR path on the DDR bus, they have the same issues with regard to flushing, and so you have to be.
Okay.
By the way, I think one of those libraries that I read about was doing a key value store. Just
yeah.
Yeah.
Sure.
I've seen some of those in the past. So what are kind of the most current libraries that are being maintained at this point? I've seen several different variants over the years. Do you have a pointer to them?
I could probably track something down. I don't know it off the top of my head, but if you go to SNIA and look for the persistent memory twig, there's all sorts of information about it.
Yeah, well, this came up in a conversation in spring. Intel did work. This is not with library you mean, but to your point, someone key value stores. I mean, Intel claimed that they had LMDB running on all PMM, and that the results were herb, and encouraged us to talk to them further about it, and then disappeared.
But they claim they'll be at Ceph.
Matt, I had a experimental LMDB backend for the key value store that was based on a much earlier one that someone had written.
Yeah, I'm aware of that.
And oh, okay, yeah, it was really slow.
Yeah, exactly. Well, okay, but it's a double buffer mmap strategy, right? No write ahead log, but on PMM that might be great.
Yeah.
I posted a link that points to this thing called PMEM-KV. FYI, if you're interested. Well, it's got that page is a bunch of different libraries, but at the bottom, of course, is PMEM-KV. Don't know how well these work. So I'm not.
Sure, that's always the caveat.
You're saying PMEM DK contains PMEM KV?
Yeah, at the bottom of the page.
Sure. So the only thing with the pglog, Ben, is that it'd be really swell if we didn't have to have it going through the whole key value interface like we do now, because it's just ridiculous how we're storing pglog entries in the database. I mean, it's just so
there's no reason to do that.
Suited.
And there's no reason to do that in PMEM.
And there's a bunch of APIs.
It could be a very simple way to get it moved over there, though, without much code change.
Log entries aren't fixed size, though, right? But in theory, you could do a circular memory with a union maximal size or some crude thing.
In theory, you could use like a very large maximal size per entry and kind of
waste a lot of memory, but get lots of performance.
Exactly.
Always the trade-off. Makes the hardware vendors happy. Sorry.
Even if we did the current in-memory representation, if the transaction issue could be solved, I mean, that would be fairly straightforward at that point, right, Josh?
Yeah. And
it's probably still.
We're not really tied to the key value piece there.
Right. It's just one of the options.
Exactly.
Josh, what is the in-memory representation right now? Is it just
Something
like a
like
giant?
a STD list or something.
Is that across all PGs or is that per PG?
Per PG. Per PG.
Per PG. So we do already have like a per list or per PG list in memory, it sounds like then, Brett.
Exactly.
I'm sorry. Yes, I heard my name, but I have no idea. If you ask an architectural question, I don't know.
It sounds like right now we already have an in-memory list representation per PG of the PG log. It's not circular, it's just a list, right?
Yeah.
So
Yeah, and it may be,
new stuff.
I think it's referencing some of the buffers that are coming off the wire, so it might not be trivial to just slot those right directly in so that everything is in one spot on persistent memory. And we need to do an extra copy to do that, but that seems pretty straightforward.
Well, could the buffers not? I mean, if we're using NVDIMS, what's wrong with the buffers being in NVDIMS?
Well, you probably don't want to put all your incoming data onto NVDIMS.
I don't know. Assume money's no object. Is there another reason not to?
Right endurance.
They should be just as have just as much endurance as normal DRAM, right?
As long as they're the battery back things, right?
That's what I'm in my head differentiating between PDIMs and NVDIMs.
Money often is an object. I mean, I'd like to see designs that have a range that suit a range of price points.
Absolutely, but for me, I like to think by pulling things apart and saying, okay, let's assume, Infinite X. What does it look like? Assume you change the change.
Yeah, but that isn't the first thing that leads to my mind that all packet decodes are into persistent memory as the base case.
I'm not even sure NVDIMs would be that expensive because the flash backing them is not going to be that expensive.
You're not going to get the same density that you're going to get with like 3D Crosspoint or something like that. You're not going to. They're smaller than what the flash back.
No, but are they as big as normal DRAM? We do all this with normal DRAM DIMMs today, right? Mm-hmm. So are they smaller than normal DRAM DIMMs? And how much more do they cost normal DRAM DIMMs?
And the reason they're smaller is because each module has to contain the ability to write the flash.
Yeah.
So
is it a physical packaging issue?
Yeah, I think so.
You can't stack as many DIMMs next to each other. You probably have to skip a slot or something.
Well, I don't know about that, but you definitely have more than just pure dynamic RAM. You have
the RAM, the caps, and flash.
Yeah. So whatever that does to it.
Yeah.
But
But remember, every time you grow by a gigabyte, you grow the supercap capacity requirements as well, right? So there is a limitation.
Absolutely, and
you're not going to get a ton of it there's this approach. You're not going to get a ton of space. So what you want to do is use it judiciously for things where you really need the transaction rate to go up, and don't care so much about a lot of space. Like, I'm not sure you want to put all your cache in there.
I just don't want to make, let's not make assumptions. I mean, I did exercises more than 10 years ago where I could hold up two 64 gigabyte memory boards with literally two like AA's. So long enough to push the memory out to flash. At least according to my arithmetic, which may have been right or wrong, but I was doing a lot of that kind of stuff back then. So I'm not
in the spirit of actually doing something. Why can't we actually do the achievable projects rather than turn it into a blue sky hardware engineering project?
All right. I just
I
ask a simplifying question, Matt. That's all.
Yeah, I think that writing all the incoming buffers to this NVDIMs wouldn't necessarily be a problem. They probably aren't going to be larger than the size of the DRAM, and PG logs themselves won't take up that much space. Tracking would be.
You want to do other things with them.
But yeah,
strange.
There may be other uses for them that would be.
Also, my other designs like InfiniBand.
But this could be a simple way to get off the ground, right?
Becomes special. When memory becomes special, other things arise that you didn't want.
Sure. Josh, can I ask you? You were talking about writing the buffers into NVRAM here, but when you have like an OSD go down and you're loading the PG log back into memory from disk, No, those buffers exist anyway, right?
Yeah, we end up copying the parts that we care about into the key value store essentially right now.
So
But
we're
the whole
doing that
point was not
copy
to,
anyway.
wasn't the point, Mark, to not do that, to relieve
Well,
RocksDB from having to handle all that?
But we can do the
absolutely.
copy
Let's get RocksDB out.
we can just do the copy into the NVRAM. I don't think that's such a big cost.
No, I mean it's just a DRAM copy. Well,
So this might extend the life of
this-
RocksDB, right? If you didn't have to use it for every single kind of transaction.
Yes,
Oh,
absolutely. But of course,
dramatically-
these transactions have a different time domain, so it accelerates those dramatically. I mean, we're consulting this on every op.
Yeah.
I think of it as exactly like the state stuff that NFS did in filers, right? We're doing our duplicate op detection basically with this now.
So Josh, would it be easier to write the entire buffer into NVRAM and just always have it available on restart, or would it be easier to do a copy from NVRAM, or sorry, from DRAM and then copy it over to the persistent memory?
I think it might be simpler to do the latter, kind of isolate the NVDIM awareness to the PG log.
Yep. Okay. And then when we start back up and we have that still populated, we just act like it's just there, like as if the OSD had been always running, right?
Yeah, exactly. Instead of our usual read log from key value store, just have our structures already there.
Yep.
I guess we should look at these libraries and see exactly how they work to facilitate that.
Yeah, I guess, because I've been kind of going back and forth and wondering if we need to do like a read from persistent memory into main memory and then treat it like we kind of treat it now, or if we can directly use it.
I thought the whole point was to be able to directly kind of use it. Right?
Well, that's what, yeah, agreed. If we can, I guess.
Yeah. So we need to take a look at these interfaces and see what makes sense.
Okay.
I think part of the point of the libraries is that I'm not sure if you can assume that when you restart the OSD, it's going to have the exact same memory address that it had in the previous incarnation, like how the virtual memory space gets laid out. So
right. So the libraries might hide some of that for us.
The libraries, I think, may do things like relative, sort of relative pointers or whatever. I'm not saying this well, but instead of absolute addresses.
Yeah, persistent independent pointers essentially.
Does that make sense?
Yeah. Just like a shared instead of a static library.
Yeah.
I'm looking over your link, Ben, at all the different things that you have access to. So we've got libpmem object, libpmem block, libpmem log.
It's kind of overwhelming, isn't it? Like, I'm not sure exactly which one of these does what you want. I don't know Ceph. I would think one of them would. Not sure.
Probably depends on how much we want to change the PG log.
Well, maybe you need to come back to this subsequent week, but I just was trying to see if this helped the discussion at all. So, at some point, I'd like to talk about a different topic. We're out of time almost, so I'll bring that up yet, unless it's
about 20 minutes.
All right. So, well, the topic I wanted to bring up, and maybe it'll be a short one, is um, Alex Calhoun has been doing some testing with the combination of the PG autoscaler and the balancer, and he got some really, I thought, excellent results with using both, where he was getting damn near perfect balancing across OSDs. And we've been having this email discussion about, well, how important is that for performance and so forth, and we need to do more measurements of that. Or he may have already done it. I got it, and it just hasn't presented the data. But the main thing I was concerned about is, in his tests, he's starting out with everything empty. The cluster's empty, and then he sets it up the way he wants it. So the PG autoscaler basically can instantaneously come to the right PG numbers because you tell it with the target size ratio what you want. But in the real world, you might already have data in the system when you start to do this, or you might reconfigure the system, add or remove OSDs, and so it's going to be a much lengthier process, and you presumably don't want the balancer and the PG autoscaler sort of tripping over each other trying to do things to optimize. So my question was, is the balancer smart enough to kind of back off if the PG autoscaler is doing things to the PG cam?
Yeah, so the balancer will only make a run when the cluster's healthy. And it only makes a very small changes at a time.
There.
So they're kind of, the idea is that they'd work together in that way. So that if you're changing PG counts, you're going through some recovery, and so the balancer wouldn't run at that point.
So it would wait and then start running when the PG count stabilizes.
Yeah.
Okay, that's perfect then. So in that case, why don't we have it on?
Well, it's not.
No, but then you could always go into a churn, right? Like once the autoscaler stops working and you have the balancer kicking in, that might not be the best scenario. But with the way the default configuration for the balancer is right now, there is a tunable when it starts making those changes. It makes like 10 changes every few seconds. If we change those to not happen as frequently, then it might not be as big of a problem.
And the scenario that I think Miha's thinking of, that I'm also thinking of, is, okay, you start out with an empty pool and an empty cluster. You get like 8 PGs for it, or 16, or whatever it is by default, right? So you start putting data in, and very quickly you start growing the PG count, like, bit by bit at a time. And maybe you're growing it fast enough there that the balancer isn't doing a whole lot of work because you're doing it again and again quickly enough that it doesn't do a whole lot. But when you get out to having enough data in it that you have a fairly big jump between them, you could still have the balancer like filling in that gap when it's still healthy, doing a bunch of balancing work, but you're still growing. So then you just kind of like, do a scaling event, which blows everything away. It changes everything around. Then you balance for a while. Then you blow it all away and scale it again. So now you've got a totally new one. You rebalance, do it for a while. You could end up like constantly in a state of either backfill because you changed everything around, you changed all the PGs around, or if you're not doing that, then you're balancing and reweighting stuff.
I think it's kind of they're independent triggers though. The PG autoscaler is based on the capacity of the cluster, and the balancer is based on the PG distribution. So if your capacity is stable, the scaler will stop changing, and then the balancer will have time to stabilize things in the distribution-wise.
Josh, what if you have like a fill workload where you're just like filling in a bunch of stuff, like you're constantly writing like logs or something into the storage? Won't that continuously trigger the autoscaler as you add more stuff and continue to fill up the disk?
Yes, but it's not going to happen like continuously. It's fairly conservative in when it makes changes. So it's only when I think it's like a 3 times threshold or something. So when you have like 3 times as much data as would make sense for the current PG count is when it makes a peak change and increases the number of PGs.
When I've done it, when I've used it, it seems like it's like during that kind of a workload where you're filling stuff in, it seemed like it was like constantly either, it was constantly in like a state of recovery doing that kind of thing because it was writing data in so fast. This was on NVMe, so
Sure. I mean, you can certainly write data fast enough on like a small cluster like that to fill things up at a rate such that it should have balanced. But maybe more important is if you know that you're going to be using a lot of data for this particular pool, you can use the target ratio for that pool, that the balancer doesn't have to keep changing as you input data. It just goes directly to that end result.
So, Josh, my argument has been that we don't start out small. We only go with fewer PGs if there's pressure to go with fewer PGs rather than defaulting to it, which I think fixes that.
I think that's a really good idea, by the way, because if you have a significant number of OSDs, then a PG count of 8 just kind of dooms you to, a really bad situation where you're just not using a lot of OSD.
I think it's kind of tricky though, because when you don't necessarily know like which pools, at what point do you decide, okay, I'm going to use put a bunch of PGs on these pools. Like when you're initially creating the pool, you probably don't want to say this pool is going to be using all of my PG space.
Why not?
Be then creating a bunch of other pools directly after that.
But then you can shrink it, right? You can say, okay, now I created a new pool, so I'm going to change the size of both of these because neither of them have much data in them yet. So it's not costly to shrink the number of PGs, right?
Yeah, if they have no data, then it would be reasonable.
And conversely, if they have a lot of data, then the rate of change of the pool size isn't going to be that big as a fraction of its current size. So you won't have that many events. Does that make sense? Like if you have a petabyte in your cluster,
you've already got data.
It's not going to happen all the time.
Right.
And in that situation too, where if you already have a bunch of data in the cluster and a bunch of PGs in the cluster, that's exactly the kind of memory or PG pressure that would tell you that your new pool maybe shouldn't be very big. That you shouldn't necessarily give it lots of PGs.
Yeah. I guess we can consider like what happens in the case of like something like RGW, for example, which has a whole bunch of metadata pools which are relatively small. And say we're just creating a new cluster with RGW, and so there's no data in it yet.
Yeah, RGW is interesting because there's like 8 pools, and like usually only 1 or maybe 2 have anything in them really.
Right. You maybe have like a huge number of PGs eventually for the data pool, and maybe a small number for the data pool.
That all depends, right? If you turn on multi-site and other things that do logging, you get tons of stuff in the log pool, etc.
Sure.
Oh, okay. So you can't really predict what.
There's also an evil and stupid pool called multipart. What is it called? Our extra data pool that stores a bunch of multipart stuff, and so if you don't do multipart upload workloads, you won't see anything in there. But otherwise, you will.
Right.
Josh, that situation with RGW, if there was no hinting at all, I still would contend that it's better because you wouldn't have all of the pools starting out at like 8 PGs. You'd all having them start out at a proportional fraction of the total number of PGs you could have. And if you did have hinting, whatever you hint, you could say, that's the ratio of stuff that it should get. Like if you say this thing is going to use this much of the total fraction of storage, that becomes a like hard ratio, and then everything else adjusts around it. So,
Yeah, I think that you're right. I think that would be better to start out with that ratio rather than the fixed number.
In the interest of time and Matt's question, can I ask a non sequitur question?
Sure.
So with straight replica, like OSDs are doing both client ops and replica ops. Like you're doing client ops for things you're primary on and replica ops for things that you're not primary on, right?
Yes.
But EC doesn't work that way, does it? Or does it still kind of
It
work
does.
that way?
Same kind of thing.
So that's the problem with the very simplistic approach of just looking at op queue depth and linking it to the messenger feedback, because you would get into a deadlock scenario if you did that, I believe. I talked through this with Adam this morning. I still think we need to figure out a way to do something, but
I'm not clear why does that do that? Why does it induce that? I mean, if you never block replica ops,
you'd have to if you differentiated the ops. Yes, that would be the next. So that my simple idea was simpler than that. It's just look at the ops.
But let's go to the more complicated one where we never block rep ops, but you can run into you have less resolution, but going to stop. It's going to be effective in a large number of cases.
So we already treat replica ops differently. We treat them as high priority already. So we go into a separate queue for high priority applications compared to
they already
regular ops.
do.
So
and
we could only condition on the low priority queue. Like that is the client.
You could only condition on a low priority queue, but you still might, if let's say you were just getting, let's say you had no client I/O, and you're an OSD but you're actually, you're getting hammered like you're everybody's replica. Is that possible? If that happened, then this still would kind of not work. I mean, I think it's worth trying and worth thinking about, but I think all the nuances yet.
I'm not sure I understand either, but I think the thing one, applying flow control at the low priority queue makes a ton of sense, and it would tend to be effective. I'm not sure it rules out all. I'm not sure it rules all the possibilities where the system can overload, but I think it helps a lot.
It would be interesting to try, I think.
Yeah, I think it would be interesting to try.
So cool.
I don't think that situation you're talking about is really a technical possibility, but I mean, in theory, it's possible, but based on the distribution of data, you're not going to be. It's unlikely you're going to be secondary for everything that's active, and primary
that's
active.
Yeah, I mean, that would be effectively a phenomenal cold spot, if you will.
Right.
But yeah. Anyway, all right. Oh, that didn't take anywhere near 10 minutes. Well, I'm sorry for derailing that conversation, but I knew this was important.
We're going.
I can't wait whenever you're.
So,
well, thanks. It's great discussion, and I really thought those, especially the balancer thing. I think that could be something that could happen to customers that exist today, rather than far out in the future.
Yeah, absolutely.
And we talked about in the core stand-up this morning.
Oh. All right.
Great discussion, guys. Thanks for bringing up the premium stuff. I think coming up with a medium term and longer term buckets for things. I'm not trying to argue against the perfect, but making it the good only. I want to see us come up with things we can do soon, things we can do later, and do some of them.
Yep.
If we could get just the PG log into them and totally short circuit the whole. Or sorry, yeah, MPG-FO.
That's a marvelous plan.
Key value store.
But that sounds like those NV DIMMs, right? Which we can buy today, right?
Yep. Yeah, I guess.
Same time, yeah. I think that's what we're speaking of. Yeah.
Ben, are you happy with the ones that you have? Is there a particular brand that we should be looking at?
I haven't done a lot of comparison shopping. Though we got them like a year or two ago, so they're kind of small. The ones we got, they were only like 64 gig. And I think we got to do better than that, probably.
I think that's plenty for the PG log and info.
Yeah, that sounds decent size.
Okay, so then
for us,
I could send you the part numbers and how we got them and stuff. It's not hard. So I don't know what kind of servers you have.
Are there any restrictions on what kind of servers you put them in? Like, did you have to buy certain? Yeah.
The BIOS has to support it.
Yeah.
Because you think about it, it's a power failure thing, right? So
Yeah, exactly.
that's why the BIOS has to understand it.
So is that more likely a newer BIOS, or is that more likely something designed specifically for that?
A newer BIOS, and I think you have to have, reasonably modern server hardware. I don't know. I don't know all the details right off the top of my head, but like I got Dell 740s that have it, and that's a fairly common model. So I'll bet you.
Brett, let's.
Supermicro has it.
Brett, let's talk about it offline.
We do that. We'll figure it out.
Yeah.
Yep.
Cool.
All right.
Cool. Talk to you later. Thank you.
See you later, guys.
Thank you all.
Later.